Now, this is kind of new for us. We are going to allow you to get a safety certificate if you made it this far. Go ahead and scan this QR code, and you'll receive a little place to open up to put your name in. So we will email you a certificate in the next week or so. But in the meantime, we're going to go ahead and answer questions that people have asked. And if you want to ask questions, please fire away at us. I have a question here, Craig. Maybe you can answer. If a pack is dropped, could this lead to an explosion?
Wow, could is as I suppose the functional word there. I mean, I suppose it could. These things are extremely robust, right? The types of shock and vibe that they're tested to is really significant. But I mean, if you drop it from a decent height, we could see something short. We could have a tear in the separator that occurs. There could be something on the connector that could short circuit. There could be different avenues that could lead to an actual explosion. So, could it? Yes. Likelihood is low, but it is a possibility.
Since you're doing so well, Craig, I'll ask you another question. Are there any protective components within the battery that will reduce the risk of short circuits?
Short circuits. Well, there's lots of protection in these things. Primarily any battery that would fail a short circuit on at least any cell. Let's start at the cell level. Any cell that would fail a short circuit on the UN 38.3 short circuit test will have to have a fuse in there in order for this to put a break in the circuit should you actually get a short circuit. So just right off the beginning with the cells, they're often fused if they're rate capable enough to create explosions and things like that. A battery pack will also have a fuse in it in most cases. There's other devices as well that could be put in there to lessen your likelihood of a short specifically. But primarily it's fusing that we're really looking at.
I have a question here as what type of training should I do with my team that handles MWD packs on the rig? Well, Excell Battery offers safety training in various ways. I recommend anybody who handles batteries goes to this type of training. We can provide that training. We don't charge for this training. We could do it over the internet like we are doing now. We could do face-to-face training. We have a summer training course on a YouTube video. We could send you the link to that, or you could find it on our Excell Battery YouTube channel. We could also send you a PowerPoint, but we'd rather, if we can, somehow interact with you on that. But we could do various things, and please ask us anytime we could do this type of training for you. So, Craig, what is the usual shelf life of a downhole battery? Is a battery stored for over 2 to 3 years considered a hazard?
No, lithium thionyl chloride has often been stated to have approximate 10-year shelf life. The shelf life itself is very long. What we're going to really be kind of operational considerations for people is going to be around the self-discharge. You're going to lose 1% or 2% a year of capacity. You've also got to concern yourself with passivation. Passivation builds up over time as a function of temperature and time. So the higher the temperature these are stored at, you will get a thicker and thicker level. There does approach a time when your passivation layer will be so thick that it's irrecoverable. But it's very, very rare to see that. So, you're going to have some operational considerations around depassing this battery, making sure it's ready to deliver the current that you're looking for. But the actual storage time is very long.
Craig, we had an acronym there. Can you explain what an STS is?
Oh,
STS means?
alphabet soup. It's a cautionary tale of our modern age. I guess we all just start shouting out letters. Sorry about that. SDS, most of you would know that one, but it's a safety data sheet. Your organizations are all obligated to have a SDS available to its personnel. So it goes over a lot of what we're talking about here in many ways. And it's sort of that quick look so that if there's an issue or incident, you can always go through that. I recommend, having the SDS, get it out, take a look through it, and just kind of refresh yourselves around what the SDS says. Yearly would be a good thing to do, I would say.
I love asking you questions, so we'll keep going. So how do I prevent charging of the cells? What should we use to prevent charging of the cells? Our packs.
The most where the rubber hits the road, it's primarily a diode block. So every pack, for the most part, most packs will have a front end diode that's keeping this reverse polarity situation from driving current. But we should be even thinking beyond that. From a systems level, when your engineering groups are putting these tools together, they should also be thinking about how any sort of higher level voltages and things could potentially dump back into a pack and be preventing it straight from the system level. But where the rubber hits the road, the packs have a diode blocking current. Leakage currents are generally quite low, but as temperature goes up, your reverse leakage can get higher. So you often want to depend on a little bit more than just the pack diode. It is going to do the job, but we should also be considering any other way that could just exacerbate that situation.
There's a question here, may have been asked before. I talked about it in the thing there, but how can I tell if a battery is completely cool without going near it? Well, there's a couple of devices you could get, like a infrared detector, like these FLIR cameras, or possibly the temperature monitor things you could buy in a hardware store. But if you do not have any way of determining the temperature if it got hot, don't go near it for 24 hours. You need to let it cool. Craig, what type of science could I use in my facility so that people are aware of dangerous goods or batteries on site?
Oh, well, we do make available a sign for your front back door that says, notice lithium batteries on site. I do highly recommend. I know that as I go around and visit a lot of your fine facilities, a lot of them have that right on the front door or in the back. It's just being a good neighbor. When the fire department has to come and deal with an incident on your facility, being aware that these things are on site is pretty important for them. So having a notice right on your front door, lithium batteries are on site, it is just a really good thing you should be doing. So certainly, if you have some concerns around that, certainly reach out and have a chat with us about it.
Let's go ahead and share our poll questions. I think everybody did pretty good here. A lot of participation. Thank you. So the first question was, which of the following should not be performed on a lithium metal battery? Well, obviously it's all of the above. You should never overheat, never disassemble, and never recharge. All those three can result in bad things happening. When a battery incident is actively taking place, what steps should be taken immediately? Well, as it probably said 10 times, evacuate, get people away from it. Don't let people get near any sort of incident. If a battery explodes in the distance, it's not going to hurt anybody. Lithium battery should best be depassivated by, of course, application of a resistive load appropriate to the battery. Don't freeze it. Don't heat it. And yeah, do not depassivate a battery was some people did answer it. That could be true. If you don't think you need to, don't touch it. It's fine. But just only appropriate way to depassivate a battery, if you choose to do so, is use a resistive load. When a battery is ready for disposal, no, it is not safe to place the battery in municipal waste. These are regulated. They must be disposed of through proper channels. You cannot air transport waste batteries, and you do not have to let it sit for 5 years before sending, but it must be sent to appropriate lithium battery recycling facility. When thionyl chloride is exposed to the atmosphere, what is formed? Well, HCl and SO2. It's a common misconception that H2S is formed. That is not part of the battery chemistry, so that will not form from the battery. It may be present for other reasons, but it's not from the batteries. And which of the following is likely to cause a lithium cell explosion? Well, any of these can cause a cell explosion. An incinerator, recharging, heating to above the melting temperature, but all of the above will cause or could cause the lithium cell explosion. Well, I think that comes to the end of our webinar here. Appreciate everybody attending. And as Craig said, I appreciate those overseas, because I know it's very late for you. If you have any questions after this seminar, please take down these emails and we'd be glad to answer them for you. Myself or Craig are always available for you. So once again, thank you for attending, and have a good afternoon.
Thanks, everybody.